hit record and we can snip it later. But so very exciting presentation today. We're going to be chatting about the embodied carbon of MEP systems and hearing from Kayleigh Houde. So quick overview of the day. So as our typical webinars go, we're going to have a quick intro with any news updates and updates for the CLF LA group. And then the bulk of the session today will be all around MEP 2040 and the impact of our mechanical systems on embodied carbon. And then after Kayleigh's presentation, we'll have a bit of time for Q&A and discussion. So a brief pause for news. There's been a lot going on since our last call, our last happy hour. The latest IPCC report has come out, which is another sort of sobering summary of the current state of affairs and how we are not moving fast enough from a political perspective on climate. And another sort of powerful barometer of the way things are changing in the industry. The SEC also recently came out and said that there are going to be more standardized inventories required for reporting embodied carbon scope 3 emissions, and that corporations that are making substantive climate pledges need to come up with a plan to back those up. So that's pretty interesting, pretty exciting. I just pause here. If anyone has any other updates or news that they'd like to share, leave it to the group. If not,
I actually learned recently, I don't know if you have any other architects on the call, that I think starting next year, architects in California to maintain their license will have to do 5 hours of zero net carbon continuing education. So those of us who are licensed in California, we already have to do 5 hours of like accessibility education, and now we also have to do zero carbon design education. So I think that's pretty exciting.
very exciting. I think we'll have to take a look at how we can adapt this group too. Maybe we can make these more like formalized trainings. Any other thoughts before we move on? Thanks, Laura. Okay, so and per usual, we're going to give like a very, very brief overview of embodied carbon just to set the stage. So we know our buildings make up a big chunk of the pie for total carbon emissions. To date, we've talked a lot about structural materials and concrete and steel and the like, and very excited to expand our scope a bit today with the discussion about MEP systems. But really, when we're talking about embodied carbon, we're talking about supply chain considerations and thinking about where our materials come from and the impacts of each of those processes. So that's important because as we're thinking about kind of the lifespan of a building, and as buildings operational systems get more efficient, this materials perspective becomes more important in a bigger chunk of the overall emissions. And particularly, we're used to seeing these kind of broken down into pie charts, and we know that each of those kind of chunks of the pie, they really vary. So looking at this today, MEP systems can have a wide variety of a range of impacts. So it's important that we track and consider what implications our design might have, which leads us into Kayleigh. So Kayleigh is a mechanical engineer working in the intersection of computation, design, and engineering as the global computational community leader for Buro Happold. Her portfolio includes system design for high-rise residential and higher ed facilities. Kayleigh's strong interest in computational design led her to her current role and has taken her to Dubai, Mumbai, Hong Kong, all around the world, with the goal of supercharging her colleagues' workflows with the power of computation via both visual programming and coding. Her industry contributions include speaking engagements like ENR Future Tech, AEC Tech, and Autodesk University, being a recipient of the AIA 2020 Innovation Award for her team's open source life cycle assessment toolkit called BOMB, and co-chairing the steering committee for the CLF's MEP 2040 challenge. So really impressive resume, and I can say anecdotally that Kayleigh is quite an impressive colleague. I know she was just giving a presentation right before this, and I've seen her giving webinars and tutorials on the BOMB tool and other trainings globally at all times of the day. So I don't know how she does it, but I'm really glad she's here taking time with us today. And I will just hand it over to her now.
Thanks, Luke. Thanks for the very nice introduction. Let me go ahead and share my screen with all of you. So really happy to be speaking with all of you at CLF LA. MEP 2040 hopefully is not a new term to you. This challenge was just released in October of 2021. The working group has been together for over a year now, though, getting the tenets of the challenge together. So this is very similar to SE 2050 and Architecture 2030, wedged right in the middle there with 2040. But this program, we're hoping it gets all MEP and systems engineers on board with making climate impact decisions that they are choosing as designers. So we'll go over some very specific efforts that MEP engineers can make to better their carbon footprint today. But also just being part of a growing body of knowledge. This is the last in the kind of built sector to come on board because it's so many different parts and so many trades. We recognize the scale of the problem for MEP and why it kind of wasn't quite as easy. Apologies to structural engineers, but you've got slabs, beams, and columns are your bread and butter. So for MEP, it's lots of small parts. So we'll be talking about the most impactful of those parts. But the goal of the challenge is that all systems engineers shall advocate for and achieve, which that word's been a little prickly, net zero carbon on their projects, operational by 2030 and embodied carbon by 2040. So Carbon Leadership Forum is supporting this challenge, and we've had the opportunity to work with the great Kate Simonin and Andrew Himes from CLF in particular in putting this challenge together. They were kind enough to host it for us on their website. So we're very happy to be working with them on this. So the commitment from signatories is first, that they would establish a company plan, some plan of action toward reducing their MEP operational and embodied carbon. Requesting low GWP refrigerants was another very clear and present thing that we were able to do in the space. Requesting EPDs. MEP has so few EPDs, especially in the US. I can name less than 10 that are available widely, and also just participating in the growing body of knowledge. So we have had our first quarterly forum was March 18th. The next one is happening in June. I would encourage all of you to join if you feel so inclined. It's up on the CLF website. So I'm going to walk through the four main components here of the challenge and just mention that we kind of have a space for both signatories, which we're stating are people who are MEP or systems engineers, and then supporters. So architects, structural engineers, manufacturers, construction management, all of those individuals count as supporters of the challenge rather than being the signatory who is responsible for placing those elements. So we do have two specific groups there. But so far we have, I think it's around 30 signatories and I think 15 supporters of the challenge at this point. We're just going to go through the first tenet of the challenge, which was establishing a company plan. So during our quarterly forum, we went through Buro Happold's company plan that we've put together. So Luke and I are both familiar with this, but just to give people an idea of what this plan could look like at this point. So to review BH's main goals is plan to reduce our operational carbon, targeting zero by 2040. Maybe moving that to 2030, since it does seem like a more present threat again. And then number 2 was to reduce our embodied carbon, targeting that by 2040. That is aligned with the challenge, setting very clear targets, evolving those targets from year to year as needed or as more information is available, and defining action items. So training needs, understanding that people do need to get up to speed as this kind of an evolving knowledge base, addressing scope gap on our projects, reviewing standards, specifications if we need to remove certain materials from being specified or hone in on certain manufacturers that are doing a really good job of walking the walk of reducing their embodied carbon. Typical details, anything across all of our deliverables, making sure that our language is all up to speed with the latest, greatest information in this space, and requesting EPDs from vendors on all projects. The more that we flood our manufacturers with requests for EPDs, ideally, the more likely they will be to produce them, especially for MEP. Our third goal was to measure and report our annual progress. So MEP 2040 is hoping to overlap with a 2030 and reporting through the DDX mechanism. That's something Buro Happold has been doing for quite a long time in terms of reporting. So it makes a lot of sense for us to lump in the MEP side with that reporting we're already doing, which is mostly MEP based on the operational side, but adding in embodied components like refrigerants, which I'll talk about in a bit, as well as sharing case studies, lessons learned, all of that information with the MEP 2040 community, and sharing progress on our website through reporting and just being really transparent around all these topics. So to take a look at our 2021 report, we shared this with everyone. So identifying our scope of embodied carbon and seeing what those reductions have been between 2019 and 2020. Or sorry, this is between 2020 and 2021. And obviously traveling emissions went down significantly there, but we had a 68% reduction, which was great, but really just being transparent about our achievements or maybe our shortcomings even. Right. So the second portion of the challenge for MEP 2040 is on refrigerants. So we know that refrigerants contribute a great deal to the, let's just say carbon, because it's at the weird space between being embodied and operational, or go over both sides of the coin. But if you take a look at refrigerants in terms of their life cycle, so they're obviously produced in the A1 to A3 phase, they're supplied in bottles or containers, they're sold, technicians will bring them out to your site, you charge your initial equipment, you utilize your systems, you top them up every year. Let's say that the bottle is recovered or recycled during that process, it's then destroyed at end of life. The leakage risk is the most, I guess, meaningful impact here. So the A1 to A3 phase for refrigerant is very, very small in comparison to the amount that actually escapes to atmosphere, which contributes to global warming potential. So that's what we'll be talking about in terms of calculating refrigerant risk. But just to give everyone an idea, commonly utilized refrigerants are R410A. Very common that that's utilized. There's legislation going into place around like the Montreal Protocol, the Kyoto Protocol, the Kigali Amendment to reduce the utilization of HCFC-based refrigerants, hydrochlorofluorocarbons. So moving into something like R32, you're taking your impact from about 2,000 kilograms CO2 per kilogram of refrigerant down to 677. It makes a really big difference. Also now in Europe, less so in the US, but I think that's because of pressure on manufacturers. They've moved into using 1234 ZE, which is 1 kilogram per kilogram. So obviously can make a huge difference here, but we'll walk through just how much refrigerant escapes to atmosphere during a typical building's lifespan. So if we take a quick look at the data sets around this, so we want to look at how long the equipment's going to last or its lifespan, the amount that we expect to leak over its life, and then the environmental metrics around this. So these are just some data sets that we've collected. Again, my background is very much data-based. I'm a mechanical engineer, but I deal in code most of the time. So codifying this into a usable tool was fairly easy for me, but these are all the data sets that I was able to amass in this space. So if we go through just a simple example of something like a chiller. So you'd expect that your building's going to last about 60 years, let's say it's 33,000 square feet. You'd have your equipment specifications here of it being a chiller, which is pretty centralized, not a ton of leakage comparative to something like a VRF system. Let's say it's 110 tons. The refrigerant charge would be about 50 kilograms, and the life expectancy for that chiller is 20 years. The leakage statistics on this per the EPA guidance is that when you install it, you leak 1%. Every year, it's going to leak 15% according to the EPA. At end of life, you would lose 5% as you're taking the system apart, and that you would assume that it was completely topped up at end of life. So the end of life remaining is 100%. And then the environmental metrics around this, which we reviewed before, are 2,088 kilograms CO2 per kilogram of refrigerant. So if you look at how much actually leaks from the initial charge of 48 kilograms, you're losing a lifetime amount of 3 times that. So if you just think about the number of canisters of refrigerant, that I think these are about 25 pounds each, that's how much refrigerant you're actually leaking to atmosphere throughout its 20-year life. If we multiply that by the 2,000 number, you're looking over 300,000 kilograms of CO2. Converting that using the EPA calculator to gallons of gasoline, almost 35,000 gallons of gasoline is an equivalency here, and 55 homes electricity use for a year. So the impact's huge just for that one chiller for 20 years. So let's scale that up to the fact that you would need 3 of those over the 60-year life. You're looking at a lifetime loss of almost 450 kilograms, almost 1 million kilograms of CO2, over 100,000 gallons of gasoline, 167 homes, and over 2,000 barrels of oil that is equivalent to. So it makes a really, really big difference. So let's compare that to the A1 to A3 of the chiller itself. So the refrigerant loss was almost 1 million, like I said, kilograms CO2. If we look at just the materiality of the chiller, so where you typically receive an EPD for the stainless steel and the copper and the insulation required on the unit, that's only 14,000. So really, if we're comparing these two numbers to each other, we see that the greatest impact is coming from the refrigerant. If we used 1234ZE, it would be 3. A huge difference. So these numbers just to show that the refrigerant is much more impactful than the equipment itself. So if we pull this perspective out to be a little bit wider and looking at the building life expectancy again, looking at the embodied carbon. So let's look at structures, foundations, and enclosures numbers. ILFI states that to be about 500 kg CO2 per meter squared. So that would put the structures, foundations, and enclosures number for this pretend 33,000 square foot building at 1.8 million. We look at our 920,000 over here. It's 50% of the embodied carbon total for all of the materiality of the structures, foundations, and enclosures. That's a huge number for some canisters of refrigerant. Then if we go to the other camp of people who say refrigeration has to do with the operational carbon because it is your cooling fuel. Let's look at this EUI for pretending this is a medium-sized office in Seattle. It's about 42 kBTUs per square foot per year. The GHG factor for electricity in Seattle is 0.33. The lifetime operational carbon for that building over the 60 years is about 8 million. That's still 11% of the operational total. So this is still a huge piece of the pie that has not historically been included, but this number can literally go to 0. So it's a great first place for us to start off with the MEP 2040 challenge and knowing that we can reduce this number down to 0, and we should. So BH has used our open source code-based BOM that Luke mentioned to create a tool that requires zero code. It has all these databases plugged into the back end of it. So you can choose your equipment type. This determines the lifespan. You choose your refrigerant. We'll choose 134A for this chiller, give it the charge, and then tell it the leakage rate that you'd like to utilize. And it gives you the lifetime leakage, allows you to see that total global warming potential, allows you to see the EPA equivalencies. So we are in the process of creating some comparison features on this as well, so that you can compare R134A to R410A to 1234ZE, as well as comparing, let's say you're deciding between 1 chiller and 20 VRFs, being able to compare those different equipment options for your building. This group is also working on reporting mechanisms. So one of our goals is to create a concise environment for people already inputting to things like the AIA DDX. So tracking refrigerants, since we know they have such a huge impact, is our first priority. So we do have conversations with Architecture 2030 and SE 2050 to just try to consolidate all of our reporting and make it as meaningful as possible for everyone. So that is something that this group is working on. The third tenet here is to request EPDs. So I'm going to assume that everyone in this group knows what an environmental product declaration is, but this was from our first forum. So this group is really focusing on what are EPDs, why are they so important, the types of EPDs that we have available, starting that process of creating EPDs with manufacturers who have not done that yet, and then also trying to give a timeline for when we could push the industry to produce certain EPDs. We know there are, let's say, 200 different types of equipment across MEP. We have to start somewhere. We have to give a timeline to say, try to do all this type of equipment first, and then we'll move on to producing EPDs for other types of equipment later on. So the reason why EPDs are so important, right now we can't even begin to really quantify the amount of embodied carbon for our MEP products. Again, we don't model everything, so that's kind of difficult. We'd have to get somewhere between BIM and then a bill of materials to understand exactly what we're putting into our buildings MEP-wise, but having a set of EPDs to refer to give us at least that A1 to A3 phase of how much embodied carbon we're putting in would be incredibly helpful. Like I said, I can count less than 10 EPDs in the US off the top of my head around MEP. There are very few of them, and they would be incredibly helpful to us. So that timeline that we preliminarily gave, and now just looking at this, feels even less realistic. So we put these pieces of equipment kind of in order here with rooftop units, PTACs, VRFs, condensing units all coming first with January 2023. And then for January 2024, things like chillers, and also having a CIBSE TM65 method here. I'm not sure that anyone in this group, if you're not MEP specific, would be super up to speed with that particular CIBSE method. So CIBSE is the equivalent of ASHRAE for the UK. And they recently produced a method along with Louise Hamo at Integral, basically to give us, in lieu of an EPD, estimation of the embodied carbon, at least for MEP equipment. So you take the raw materials and then basically fluff it up by the complexity of the equipment to get a rough number. So we're giving some CIBSE TM65 goals here, as well as the actual EPDs. So you see that those are following the CIBSE TM65 method. So those are things that have been readily produced in regions like the UK. Mitsubishi even has a nice standard format for those in the UK that they're able to pass along. So that is our goal here, to start to get EPDs worked in from MEP manufacturers. And then the final portion of the MEP 2040 challenge is to contribute to a growing body of knowledge. We know that there's a lot to be learned in this space. So the first thing that we're asking people to do is to nominate a representative to participate in the quarterly forums, as well as contributing to the working groups. So we have 4 working groups on communications and resources, data analysis and reporting, partnerships, as well as manufacturers and EPDs. So I just got out of a working group meeting right before this meeting. I am leading the data analysis and reporting group along with Kim Shen from TLC. So these working groups are really where we're doing the bulk of the work in terms of figuring out those relationships with AADDX to determine what we want to report in terms of that refrigerant space, also deciding what the data structures are, really looking at the product category rules for MEP. All of the groups are doing similar types of activities around their specific space. But it's a very exciting time to be a part of something like MEP 2040 because there is a lot of information coming online around this. So apologies if I talked a little quickly. There was lots to cover there. Does anyone have questions or thoughts on what you've seen so far?
That was great. Thanks so much, Kayleigh. Yeah, I would echo the sentiment that it's a really exciting time. And one of the things that I think the CLF does a really great job of is these different programs under the umbrella of CLF there's a lot of collaboration, right? So I love that you're working with another firm and sharing these sorts of resources. I have some questions, but I don't want to commandeer time. So I would open it up to others first. Are there any, there were no questions in the chat. I shared some links. Any questions from anyone? And feel free to, if you feel comfortable, turn on your cameras. I know it's lunch for a lot of us, so you're probably eating. Okay, I have some questions. But from like a program, so from the SE 2050 perspective, and when you're creating the program, one of the things I think is really important is engaging as many people as possible, because for us to reduce the impact of one building is great, but the scale, we don't really move the needle so much until we can really engage a lot of people. So I'd be interested to hear, Kayleigh, what your thoughts are and how you're approaching kind of casting a wide net. I know you mentioned BH had done some of this in the past, and I'm sure the other firms that might already be on this call are in a similar boat, but how do we cast a net wide enough that we get all people on board?
Yeah, I think that's a really good question. I think we have the fortune of working with people in other regions through our firm. So I think we've learned a lot actually from legislation that's been passed for refrigeration in other parts of the world. That's something that hasn't happened in the US yet. So I think being able to kind of go through the looking glass in other regions and what they're doing and being able to utilize PCR setup in Europe so that we can start to establish more EPDs has been really helpful. But I think just trying to make the challenge as inclusive as possible, like we have signatories and supporters, a space for both audiences here. Even if you don't spec MEP products, you still could have a lot of useful information as an architect or as a structural engineer, or even just those overlaps of things where, you know, having triple pane glass might be something that reduces the operational carbon greatly, or you don't have to have radiant heating anymore. And I think really looking at the whole picture rather than one individual choice around something like embodied carbon is really valuable. So having as many voices in the room as possible. But I think we've really tried to expand this challenge out to not even just be US specific. We do have a few people from Canada joining it, but ideally it would just be everyone in the same boat, collaborating, co-creating together.
Yeah, I love that. And we have a number of different disciplines represented here on the call, from sustainability, structural, and MEP. So I think having this background gives everyone sort of the ammunition to at least sort of poke at and ask the questions of different people on the design team. One other question I had, so you went through some of the different databases, and one challenge on the structural side is giving estimates on like an intensity per square foot. I wonder, for MEP, is there a good way to estimate when you have little to no information, or as someone without that background, like can you relate it to a square footage, or like, because it's very much related to the actual equipment, and I don't know if that equipment depends. I would imagine it's probably dependent on square footage or something the like, but
it's really difficult, I think, because MEP it's so many small parts, right? So even if you just think about like the piping in the building, there's a lot of it. And I think in terms of evaluation, it's a lot of questions. Like I've worked with Shivani, who's on the call, in terms of like coming up with a list of questions, just so it could even be assessed in the first place, to say, what was your sanitary system made out of? Because you didn't specify it inside of the model. And I think to even take a pass at evaluating those materials or trying to get that number for embodied carbon for MEP is pretty difficult, because you don't model everything. You don't specify all of the materials in the way that a structural engineer might. So it's quite difficult to kind of understand that. So I think what we're focusing on is, what are those high value items that we can say, please don't use really heavy black steel in your projects because it's bad for the environment. But we also don't want to say use PVC for everything, because we know that has really bad health impacts. So I think we're in a tough place right now in terms of making sweeping statements about things. Refrigerants were one where we're like, we know we can definitely say, just try to get the lowest GWP refrigerant you can get. So I think it's kind of a difficult balance to understand what exactly we want to target next. I know there are lots of studies being done, but we know centralized equipment doesn't leak refrigerant nearly as much. So that's also a big thing. So it's changing your refrigerant out, but also just not speccing VRFs is a pretty clear statement that we could probably make at this point.
Yeah, and that low-hanging fruit is really helpful to understand, even from a starting point. But to see the relative impact, like the 50% slide is a pretty powerful slide when you think about a whole building. I know that's like over time, so it's a little bit different, but that's a really powerful information.
You mentioned, those things, the R1234 becoming kind of available in Europe, and as an architect, I'm not the most, in the mix when it comes to, choosing these, but I was just wondering if there's something I could kind of guide some of the engineers and art teams to, in terms of in America. Is there something that has more availability in LA or nationally in terms of a low GWP alternative?
Yeah, I think it depends on the manufacturer on the project. So it really depends who the team is working with. But I know on a project that I'm working on, the client specifically said, let's look for next gen refrigerants, because they were aware that it was a bad idea to spec things like R410A. But I think it's up to the client to kind of drive that a little bit, but also the MEP engineers starting that conversation with the manufacturer to say, can you support next gen refrigerants? If not, maybe I need to look for another manufacturer, and starting to specify which refrigerants we will accept in our specs as well. So just starting to get that into the realm of awareness of the MEP team is really important. So maybe just asking those questions and saying, did you explore other possibilities or other manufacturers? And I think what we're trying to do with the manufacturers and EPD groups is really kind of put those manufacturers on a pedestal who are doing the work to be able to have their equipment support these other types of refrigerants, publicizing them a little bit more so that people know, oh, this manufacturer does support these things, so I can spec them on my project. So that's the goal. But yeah, I think starting the conversation or just asking the question is very helpful as well.
So no VRFs, no 410A. I think there's some hope. You talked a little bit about policy, but if there are like some aspects that are eliminating specific items, I would hope that it seems like something policy would be a pretty effective way at reducing. And there have been, I mean, I think it's the Kyoto Protocol, right? That has been looked at as a huge success for limiting ozone depletion. So we can get it right at times. So hopefully we can do the same. Use MEP 2040 as a great platform to build recognition of that. I have one other question about, so the refrigerant leakage is something that happens over time. So I feel like a lot of times we get latched on to new buildings and new design. But I wonder too if we have a big need to address existing buildings from an energy perspective. Do you see potential with kind of aligning that with also switching out the refrigerant or other systems that may be currently leaking and causing these emissions?
Yeah, that's a really good point. Yeah, I think we tend to think about buildings as being new, but if you think about the 20-year cycle of something like a chiller, if the next chiller you spec, it's not like you're going from, I don't know, steam to natural gas on your building. Refrigerant's something you add in, you ship it in anyway, so you could make that swap out if you wanted to. So that is a very good point. We can make better decisions even on buildings. They're not locked into using that refrigerant forever. If you're going to get a new chiller, try to get one with a better refrigerant option. So that was a very good point. So thinking about this more holistically rather than just on new builds. So anyone doing retrofits on buildings to take this into consideration as well.
It seems like from an architecture perspective, David, that might be a great place to get involved too. With that leakage, there's one other overlay on the embodied carbon side is we're seeing more on the healthy materials. And if this stuff is like, I don't know what that 410A is made out of, but I imagine it's probably not great if it's contributing like 2,000 times as much as carbon to the atmosphere. Are there any health impacts to that as well? Like, do we?
Don't know that off the top of my head. The project that we're doing right now for ILF5 that I called you about yesterday might shed a little bit more light on that. So we're doing a bit of a study into the healthy material impacts of different building components across structures, MEP and interiors to figure out what's the cancer red or the PBT or the reproductive effects of this so that you're not just looking through the embodied carbon lens. So I think refrigerants would probably be a pretty nasty one if I had to guess. It's not in the Quartz healthy materials data set. So it's really hard to get open source data around healthy materials. But that would maybe be one for us to add as a one-off from that data set because I bet it's not great.
Yeah, really insightful and something to keep an eye on. Are there any other thoughts, questions from the group? Folks know that maybe this is also something I know there are a couple of folks from USGBC and the AIA code groups. It might be something to bring up to the city as part of their building decarbonization efforts. Okay, if there aren't any other thoughts, I think we'll move on. We'll just do a quick wrap up slide. Oops. Let's see, a couple other updates for, so I shared the link to the MEP 2040 challenge on the CLF website. One other thing I wanted to highlight to the group and encourage folks to get involved with is this benchmarking study. so they're doing a second round of, originally, I think they had 900 or so buildings to benchmark different impacts by kind of archetype. But as folks might know, it worked out that there's sort of not apples to apples. People use different tools to report data, and so it's I would say of varying success. So readdressing this like 4 or 5 years later, if people are interested in getting involved in any capacity, I'd definitely recommend filling out this questionnaire. And I think it's an important thing for our industry to move forward and really recognize the how well we're doing or not doing. Let's see. And then also just encourage folks, if you have questions, the CLF community page can be a great resource. I've also, there have been a few folks on the structure side using the Slack channel for our own smaller group, both from the CIOSC event from a few weeks ago, and like just the CLF LA chat. It can be nice to have a smaller group and a little less pressure at times. And then looking forward, we I think so the next meeting we're going to do kind of trade-off between webinars and happy hours. Now that COVID situations are getting to be in a better place, we had our first happy hour last month, and next month we're going to look to have that. I think it's going to be hosted by Suffolk Construction downtown, and then we have a few other firms that are just we're gonna make the rounds and have different folks host. So if you're interested in having your firm host a happy hour or be part of that, please reach out. We'll put you on the list. And it was really nice getting together last time and actually meeting people in person. Pretty fun. With that, let's see. Other instigator, organizer folks, any comments, anything I missed, or comments from the group?
I just want to think that was great. And I mean, I'm still getting over the shock at seeing how much the damage the refrigerants were doing. That's just insane.
Yeah, Kayleigh, I think you have us shook. That 50% number is gonna really, I don't know if I'll sleep tonight. Laura, anything else you want to add?
I don't have anything else to add. Just thanks to Kayleigh for presenting, and thanks to everybody for joining.
Thanks
Can we give a round of applause? Thanks so much, Kayleigh. Really appreciate it.
Thanks for having me.
And thanks for your leadership on this overall. I think it's a really important.
Thanks.
Clearly.
Thanks, Kayleigh.